So here's the Hallicrafters SX-18 on the bench again, and just did a little follow-on video from the one I posted earlier today, which got cut off short because I pressed the button on the phone and switched it off about half a minute before I was supposed to, so the end got cut off. In that video I was showing the analog setup to look at the IF response curve of the set. And the analog setup is the HPH601A sweeper, an 8600A frequency counter and digital marker generator, and displaying the curve on the tech monitor. At the moment I've got the receiver set up so it's actually, the response curve is being plotted on the spectrum analyzer. And it's got the crystal out of the circuit at the moment, so that's the sort of IF response curve without the crystal in circuit. What I wanted to just show here was how long it takes to change the response curve on the screen of the spectrum analyzer. Now here I've got it looking at an average of every 5 sweeps, and it's got a 50 kilohertz span and a 300 hertz resolution bandwidth on the spectrum analyzer. So it's taken quite a while. It's taken about 6.7 seconds to do the full sweep, which is quite a time. And compared with the sort of real time of using the analog equipment, it's not that good for trying to tweak the IF transformers. Now to get a quicker response, we can reduce the span quite a bit. And we can reduce the resolution bandwidth, which is okay for looking at the sort of a broad frequency response as here without the crystalline circuit. Now what I'll do is I'll switch the crystal into the circuit now, and you can see it just starting to affect that trace. So it'll take about 5 sweeps. So it's over half a minute to catch up with the actual response curve, and you can see it's changing on every sweep, which is not that good if you want to just to see how, say, the crystal phasing control is operating. And tweaking the crystal phasing control, it's going to be a while before any response is shown on the screen here. You can see the typical crystal response curve is starting to appear now with a notch and a peak. But it's not really in real time. It takes a while to build that up. I can change the span to say 3 kilohertz. It's even slower because it's now automatically gone down to 30 hertz resolution bandwidth. I can increase that manually to say, if I do I don't know, say 300. So it's now sweeping quicker. It's now got a 6.7 sweep time again. You can see the crystal response curve is appearing. The definition is not that good because these notches, it's actually deeper than this, so you can't really see that resolution bandwidth. And as I change the crystal phasing control, say over here, which should give us a bit of a deeper notch, takes a while to catch up. Or on the other side here, it will should give it more of a peak and less of a notch. But again, I can't really tell where that is without waiting quite a while, which is a bit of a pain. I could say put the span back out to, I don't know, say 20 kilohertz, and again, it takes a while, eventually get there. So what I'll do now is I'll just switch off the spectrum analyzer. I'll put the analog equipment back on into the circuit. So it's to do that, disconnect the tracking generator, and this will go into the sweep output, and the output of the detector is already coupled into a little box over here. So the output of the detector is into this box now. Goes into the Y input of the monitor. I'll switch the crystal out. And that's the IF response without the crystal in. Switch the crystal in, so instantly we get the response. You can hear the sweep on the audio, and as I turn the phasing control, you can instantly see the effect. So go for just a peak, and go for a deep notch. And you can see that happening in real time. Doesn't quantify it too well. I can put some markers on there with the marker generator, but they're not particularly good. I don't even know if it's working correctly. You can see the markers are on the screen now, and you can move those around. That marker there is at 464.9, so that's the center of the AF bend. Looks like I've got a bad connection somewhere. Anyway, so you can see it's definitely more usable as a sort of a qualitative assessment of the IF, whereas if you want a quantitative assessment, the spectrum analyzer is definitely the way to go. There we go. I just thought I'd do a little demonstration of both techniques. I've actually got a third technique I could use, is a homebrew wobulator I made several years ago, which sort of works very, very similar to this analog setup here, but not quite as good. There we go. The Hallicrafters SX-18 IF response curve.